Okay, in the previous video I was assembling the circuit board. I didn't want to bore you with too much because it was quite long. Um, because so anyway, this is the board. What used to be on the breadboard, which was basically about a lot bigger than this. Anyway, it works. So my input trigger coils come in on this socket there. Power supply, which it could run off a PV3 9-volt battery because this circuit board uses just a, 9 milliamps when it's running, 20 milliamps when it's not running. The reason for that is that the transistors that are switching in and out, it's actually upside down by the way right now. So if you want to read the text, you'll have to look at it upside down. Anyway, no worries. Anyway, the output basically goes through this lead to drive the MOSFET board, which is over there, the green thing. Ignore the other board because that's not connected. I'm just using the same heatsink. So anyway, I just wanted to show you it working. A short video just to show that it does work. So we're all powered up. We're running at 16.78 volts DC, and the current when it's running should show up on there. Because this is pulsed basically twice every revolution. The rotor assembly, because of the way the magnets are orientated, it's I suppose you could call it half wave pulsing because it's pulsed twice per revolution instead of 4 times. So there's 4 poles. I mean, there's north, south, north, south. So instead of it pulsing on north, south, it basically pulses on just the north poles, for example. So you get the idea. Anyway, so it's halfway basically. Anyway, right, so just to flick it to get it started, and right. That's going. Just have to get this set right. I ain't got my revolution counter hooked up either. Well, anyway, you can see it going. It's driving it. You might see a flick on the LED. So yeah, so we're actually drawing a bit more current than before though. I think that's because of it's because the supercapacitors that are being charged up are very flat right now. So I'm actually trying 460 milliamps right now because the supercapacitors are only at 3.77 volts, and they're actually I'll just try and show you. I'm charging the right over here actually getting about so about 3.82 volts, and they're charging up 130 milliamps coming in. So right up there. So long way away, and it's only going through a thin wire right now. So let's put this on current, and the current at this end is 164 milliamps. It's actually slowing down a bit now because the meter's actually more impedance on it, but the current is actually gone up a bit more now. But yeah, it's because of the drag on the system. But yeah, I don't want to. It's late. It's early, whichever you want to call it. And I'm going to bed soon. RPM is probably, I don't know, it'd be about 3000 RPM. The meter's not hooked up right now. Let's have a look. I'll connect the battery a minute. just down here. Right, yeah, it's about 3,300 RPM. So, not bad. Considering it's under quite a bit of load. Anyway, the next phase will be to build the AC switcher circuit. I might as well just mention a little bit about that. That's the switch the output circuit to minimize the drag on the system. I'm just trying to find the diagram. Where is it? I'm looking over here. There it is. Right, it's not finished, so it's a bit of a mess. This is the preliminary diagram, but I'm redoing it, so I'm redrawing things out. But it's got a lot of diodes in it. I should call it a diodegram, because there's more flipping diodes in this than there is in, because of all the AC, and because I'm switching AC. I've got to do it basically twice, so I've got to switch each half cycle or a separate system. So there's the top section and then there's the bottom section, and this is just the basic stuff right now, because yeah, there's a lot more stuff to work on. I drew this out just to try and work out how to do it, and so there's obviously lots of tweaks, and this is all going to get breadboarded. I've got to clear my breadboard, my prototyping board, clear all the most of the stuff off it, and then I can start to plug diodes in everywhere, which is well, there won't be many capacitors, that's for sure, because with it being AC, the only capacitances will be for coupling the to the actual BS170, the BS170 transistors, because I'll be using two, and I'll be switching each half cycle. And I've actually done away with that, where I've connected them through diodes to the single socket. I've decided I'm going to use two sockets for it'll be two sockets, so there's basically a socket for each input of the AC and each output, so yeah, it's going to be a lot less complicated. But I haven't printed that one out, so yeah, this is just basic stuff at the moment. It looks kind of messy on here, but really it's not that complicated, really. I've got to put some trimmers in. There's going to be some adjustable trimmers on here to adjust things. Anyway, that's all really for now. At least you can see that the circuit board's working. That's all. But the only reason let's turn the power off. Let's disconnect it, and we can watch it slow down, and we see the LED as it flickers. You'll see the cycles start to appear on the LED. The camera doesn't really pick it up too well, but it definitely latches okay. When it went dimmer, that's when the latching was no longer working, but it latches really well. Anyway, thank you for watching. We should have some more videos in a couple of days.